My name is Dan Riley. I'm the Warning Coordination Meteorologist for the National Weather Service Forecast Office for the Houston and Galveston area. I'm going to talk to you now about hurricanes, hurricane hazards, and the forecast for the 2020 season. So our Weather Forecast Office is located in League City, and as I said, we're the Houston-Galveston Weather Forecast Office for the National Weather Service. We're actually housed in the Galveston County Emergency Management Facility, and our forecast area is shown in the lower right there, 23 counties there in southeast Texas. We issue forecasts and warnings for severe weather for southeast Texas of all types. The National Hurricane Center plays a huge role in hurricane-related watches and warnings. We coordinate with them on those and then communicate them to the local officials and people in this area. So what is a hurricane? A hurricane is a weather system, the type of weather system called a tropical cyclone, which derives its energy and forms out over the warm ocean waters. Tropical cyclones can vary greatly in size and intensity, can be very large, can be very small. They rotate counterclockwise, they circulate counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. In the Atlantic, a tropical cyclone is classified as a depression, a tropical storm, or a hurricane based on its maximum wind speed, where the hurricane is the strongest classification. And as I said, the hurricane draws its energy from the warm ocean waters, which generally need to be 80 degrees to some depth. And that's why we have a hurricane season, which runs between June through November. Every storm is different, contains some combination of the hazards shown here: damaging winds, storm surge flooding, flooding rains, and tornadoes. And so, for example, a storm like Tropical Storm Allison wouldn't have a whole lot of wind with it or storm surge, but would have flooding rains. Looking back, Alicia had multiple hazards, but certainly it had the damaging winds near the center. Alicia was a Category 3 hurricane, the last Category 3 or higher that we've had impact this area directly. Hurricane Ike, a high-end Category 2, very large hurricane. Big impact there was the storm surge flooding. You can see the aftermath on the Bolivar Peninsula with the seawater passing over that stretch of land, wiping out a lot of structures there. Harvey, flooding rains for sure was the biggest impact. Not a whole lot of wind for our area, although the mid-Texas coast had a tremendous amount of wind from Harvey. But for us, it was really a rainstorm. In fact, a record rainfall amount and catastrophic flooding. And then tornadoes. Some tropical cyclones will have a lot of tornadoes. Others will have few or none. Harvey was an example of one that had at least 22 tornadoes, probably more than that. So of those hazards, which are the most dangerous? The most dangerous is going to be water-related hazards, especially storm surge flooding and flooding from heavy rain. The two together account for about 3/4 of all fatalities related to tropical cyclones. And then you look at the surf and rip currents, that's a bit more. The wind and tornado threat, certainly significant, certainly dangerous, but only about 11% of the fatalities with those wind-related hazards. So the water-related hazards, when you add it all up, almost 90% of fatalities from tropical cyclones. So we do rate the hurricanes, and usually they're rated based on the maximum winds. And the intensity scale we have for that is called the Saffir-Simpson Hurricane Wind Scale. As the name implies, mostly describes the wind hazard. It has some application to the storm surge, but it's really not related to the flood potential or the tornado threat at all. And so don't think of just that one number as an overall severity index. You need to consider the other hazards beyond wind, but the scale is useful in giving us an idea of how bad the winds and the wind impacts can be. So you can look at the table there in the lower left, and you could see Category 1 winds, 74 to 95 miles per hour. That's very serious winds, very dangerous winds, even at the Category 1 level. And then you go up the ladder there, Category 3, 111 to 129, a storm like Alicia. We'll see in a moment, Harvey, nearer where it made landfall, was a Category 4. And the winds for Harvey were well up in that 130 to 156 mile per hour range. And then many more details can be found at the link shown on the slide. So let's look at the different parts of the hurricane now. Imagine we could take a hurricane and sort of cut it down the middle and look at a cross section. So right in the middle, we have the hurricane eye. If you view that on satellite, it would be like a little hole in the middle of the storm. If you were standing in the eye, you could look all around you. You would see a ring of thunderstorms most often, and maybe even clear sky overhead. The winds are very light inside the eye, and I can confirm that because Hurricane Ike came right over the weather office in 2008, and it was very still, very eerie in the eye itself. But the ring of thunderstorms around the eye, that's where the strongest winds are housed in the hurricane. So that's a very, very dangerous part of the hurricane, is the eye wall, that ring of thunderstorms around the center. And then as you go further out, you get these bands, these spiral bands that can contain tornadoes, very heavy rain, and gusty winds. And as we'll see, the spiral bands played a huge role in our impacts from Harvey and Imelda. Here's a look at Hurricane Ike now on radar, again talking about the different parts of the hurricane. And so looking at this, that light blue area, there's no rain there in the middle. That's our eye right over Galveston Bay at this time. The ring around the eye, where you see all those reds and yellows, that's the eye wall. Typically the highest winds are felt in that eye wall region. So if the eye wall of a hurricane passes over your area, you're getting the highest winds that storm has to offer. And then as you get a little bit away from the center, you can get bands that spiral out from the center, so-called spiral bands. That's where we can get tornadoes and very heavy rain and gusty winds. So here's a look at Hurricane Harvey around the time of landfall. It was a Category 4 down the mid-Texas coast where it came in. And you see that image, that satellite image in the upper left. That hole in the middle is, of course, the eye. And interesting image here. This satellite image sometimes is referred to as a nighttime visible image. You can see the tops of the clouds, white tops, and the city lights through those clouds in some areas. And then the radar image is in the lower right, and you can see around the city of Rockport here, this sort of semicircle around the eye is the eye wall in this case, hitting Rockport directly. So you would expect that town would get very devastating impacts in the eye wall of a Category 4 hurricane. On the lower right, this is actually a measurement from our radar as well, where we can actually measure the wind speeds directly in the hurricane, actually from the movement of the raindrops. So in this case, the winds in the bright blue here expected to be up in the 140 to 150 mile per hour range. And if we look at the data from Harvey's landfall location there between Port O'Connor and Corpus Christi near Rockport, you can see in the lower right some of the measured wind gusts ranging from 125 to even 150 miles per hour right in that ground zero area. So as expected, with those type of winds, you do get significant wind damage, maybe like you would with a tornado, for example, and you can see an example of that in the upper left. So if we do get a high category landfall direct hit from a hurricane, we'll definitely need to be concerned about the wind damage. The water hazards, as we said earlier, these are the most deadly, the most dangerous, rainfall and storm surge flooding. So when do we need to be especially concerned about flooding from heavy rains? You can see the 5 factors here: the size of the storm, the motion, the rain rate, vertical wind shear, topography, and any kind of frontal boundaries around the area. The most significant is likely number 2 there, the storm motion. When we get very high rainfall, let's say greater than a foot from a tropical cyclone, almost always it's from a slow-moving storm. In some cases, the storm comes in, slows way down, maybe even loops over the area. Anytime we have a forecast track like that, we need to really be concerned about flooding rains. The size of the storm, also a factor. The rain rate, the higher the rain rate equals more rainfall, of course. So you combine rain rates of 4, 5, and 6 inches an hour in some cases with slow motion, you're going to get a lot of rainfall. And we've seen that again and again. Not only from tropical cyclones, but also slow-moving thunderstorms can have this effect. So let's take a look now at Harvey, and I'm showing you a radar loop there on the lower left side. You can see the Eyewall making landfall there, but look over our area in southeast Texas. You see the spiral bands pivoting over our area repeatedly. We had one, if you remember, Friday night. Here comes the Saturday night band that just sat over this area, dumping tremendous amounts of rain, in some cases 20 to 25 inches of rain in just that one night. And the storm, you can see it now drifting back over the water, very slow motion to it. As we said earlier, slow-moving tropical storms and hurricanes, think right away, real concern about flooding rains. And when all was said and done, Harvey dumped greater than 50 inches of rain over a very large area. You can see that in this rainfall analysis here. The dark blues greater than 50 inches, the purples greater than 40. So a huge footprint of just tremendous amounts of rain. The record amount actually 60.58 inches near Nederland, Texas. And Harvey wasn't the only type of storm like that we've had to deal with, unfortunately. If you look at the 2 top images, we're comparing Harvey in 2017 with Imelda in 2019. And some of those Imelda amounts were also over 40 inches, kind of unbelievably. Not too different for those areas than Harvey. So the difference there you can see right away is the size of the area impacted by Harvey was much greater than Imelda. But Imelda was also one of the wettest storms on record, and it coming just a few years after Hurricane Harvey. Looking at Tropical Storm Allison versus Harvey now on the lower part of the frame, you can see Allison had a relatively small area of greater than 30 inches of rain over parts of Houston and Harris County. But if you compare that on the same color scheme with Harvey, it looks like so much less and over a much smaller area. So that's kind of hard to believe, because Allison had such a tremendous impact and was thought at the time to be kind of a historic record storm in some ways. But Harvey almost dwarfed Allison in the scale and the size and also the intensity. But Allison certainly significant. 3 feet of rain in an urban area, slow-moving tropical storm. You can see some of the flood impacts there from Allison. So it doesn't have to be a Harvey. Allison is right there, not quite to the level of a Harvey, but certainly enough for catastrophic flooding over the greater Houston area. On the right, you can see sort of a before and after for I-10 back in 2001. Notice also it's a June storm. This is an early June storm, so we can get tropical cyclone impacts very early in the hurricane season. Let's take now a look at Hurricane Ike in 2008. You can see the radar on the right-hand side, the counterclockwise circulation, Ike making landfall there, and then steadily lifting to the north and then the northeast. So given the speed of motion here, we wouldn't expect for this to be a huge flood event, and it really wasn't. The bigger issue was the high winds and especially the storm surge at the coastline. Those were the greatest issues. The wind factor, because it was such a large hurricane, there were power outages over a huge area. So So that also was a big impact from Hurricane Ike. Here's a look at some scenes from the surge zone. Notice all the flooding there on Galveston Island as the storm pushes water onto land. I do want you to take a look at the image in the lower left. Those are people that may have been caught off guard by the early rise in the water level. Anytime you have a hurricane or large storm coming in, quite often the water level rises well in advance of the winds, and that's certainly what happened with Hurricane Ike. You were getting a water rise a good 24 to 36 hours prior to the arrival of higher winds, and so people that woke up Friday morning thinking they could get out of Galveston or Bolivar already were trapped because the water was covering the roads, and so at some depth. So there were a lot of rescues that were made ahead of the arrival of the winds. And then certainly you can see the devastation here, Bolivar Peninsula from the storm surge. You know, just a horrible scene here with the high water surging in and then pulling out, capable of doing a tremendous amount of damage. So the key point here is this is not someplace you want to be during a storm like this. You know, your local officials are going to advise evacuation in this scenario, and you really do want to heed that notice. So what areas are at risk of storm surge? And one way to assess this is to look at the elevation of the land. On the right-hand side, that's what I'm showing. I'm showing land elevation above mean sea level, and you can see the legend there in the center of the slide. And so all those areas in green are sort of on the order of 5 to 10 feet. The yellow, more like 10 to 15. The orange, 15 to 20. And then those red zones, 25 to 30 feet above mean sea level. To a first approximation, if that water level is above the land elevation, you're going to have the potential for flooding. So a storm like Hurricane Ike, which had surge on the order of 10 to 13 feet around the bay, it was really a lot of those areas in green you see there that were underwater. It would be unusual to get a storm surge above 20 feet. So if you're in those orange and red areas, you're kind of on the edge of kind of a worst case surge zone. If your area is not shaded by color on this map, you're likely not going to be affected by surge. So you don't have that storm surge flooding risk. I do want to point out too the evacuation zone map in the lower left. Notice the similarities there to this sort of this surge risk map on the right, and you can see how the evacuation zones are actually based in large part on the storm surge threat, to some extent the wind threat as well. So let's do a quick walkthrough, kind of a worst case storm surge flooding for different categories. And again, storm surge depends on more than the category, but this just gives a first approximation of kind of a worst case. So these are the areas that could be flooded by a Category 1, a Category 2, a Category 3, and keep in mind the scale on the right. The red areas are greater than 9 feet above ground level, Category 4, and a Category 5. Now, I encourage you to take a look at the link on this slide to kind of play around with these maps. You can zoom in a little bit, focus in on certain areas to get an assessment of your risk to storm surge. The hatched areas are leveed areas. Those are areas where it's hard to show how deep the water would be. You know, presumably the levee would offer some protection up to certainly the height of the levee. So there is no value for those areas. Let's talk about tornadoes and waterspouts. As I said earlier, some tropical cyclones have a lot of these. Others have a few or none. And but when they do occur, they quite often form in the spiral bands on the right-hand side of the track. And that was certainly the case with Harvey. We had these sort of strong spiral bands here, and each of these thunderstorms within them, most of them were actually rotating. So it was quite a challenge to try to determine which one of these would have a tornado. And as I said, several, at least 22 did. All right, so let's kind of wrap things up now. First, let's take a look at last year. You can see all the all the tropical cyclone tracks. There in 2019, there were 18 named storms. Named storm meaning at least tropical storm level, and that's well above the average of 12. And there were 6 hurricanes, with 3 being major, category 3 or higher. So the number of named storms was well above average. The number of hurricanes was right at average. Bottom line is, overall, it was an active season. And then notice the Gulf of Mexico. We actually had 5 tropical cyclones form right in the Gulf of Mexico. That is unusual. That's only that does tie a record for the number of Gulf developers with 2 other years. So in one of those Gulf developers was Tropical Storm Imelda. Let's take a look at Imelda now. You can see the circulation with Imelda moving inland. But notice on the backside, the rain bands that formed. Once again, it was sort of a spiral rain band that played such a large role in producing our, just tremendous amounts of rain and flooding for areas, especially as you get a little bit east of Houston, toward Winnie and Beaumont and up into Liberty County. And the Gulf developers present challenges because they can form and come in with very little notice. So it's the time to prepare for these is now, and not wait till they actually form, because you may not have enough time at that point. The forecast for 2020 was issued just yesterday on May 21st. And the forecast from NOAA is 13 to 19 named storms, the average being 12, 6 to 10 hurricanes, the average 6, and 3 to 6 major hurricanes, the average 3. So we are thinking, and NOAA is thinking, that it will be a more active than average season in the Atlantic overall. What we don't know is if our region will be impacted this year. We can't predict the storm tracks ahead of the season. And as you look at the names on the left-hand column, we've already had 1 storm. We've already had Arthur in the Atlantic. So even though we're not officially to hurricane season, we've had May storms in many recent years. So bottom line is, we need to prepare no matter what the forecast is, but the thinking is a more active than average season this year. And so as we go through the hurricane season, you're going to want to prepare, and part of that is to stay informed. The best way to do that is to follow, look at our website, weather.gov/Houston, also hurricanes.gov for the Hurricane Center. Follow our social media. Stay connected with your local Office of Emergency Management for important information, and we'll just go through the hurricane season a little bit at a time. If we can get well into October, our chances go down. So the peak of the season, definitely August and September. We can get storms, though, really any month during the hurricane season. And so that's all I have for this video. We'll also prepare more of a preparedness-oriented video. And like I say, it's also great to check your local emergency management office for additional preparedness information. Thank you all.